Let's touch a little on how ecosystem-based mitigation and adaptation can work to synergize these activities and maybe maximize the chances of meeting the potential for land biosphere as climate mitigation in climate mitigation. You can start with what has already been envisioned in the shared socioeconomic pathways. So the representative concentration pathways are then translated to shared socioeconomic pathways, which consider various land use change regulations, productivity growth, economic impact of food consumption, and international trade, globalization, land-based mitigation policies, and so on. And each scenario, SSP1 to SSP5, have options of remaining sustainable at this end and almost business as usual, and not worrying about the costs of adaptation and mitigation at this end. I won't go into the whole table, but as an example, you can see that this would require strong regulation to avoid environmental trade-off when it comes to land use change regulations. Whereas the SSP5 has medium regulations and a slow decline in the rate of deforestation. So it's the option of economic growth versus climate change mitigation and adaptation. And these are kind of seen as the ways society could potentially evolve in terms of managing the trajectories of future evolution of our planet and our role in it. If you think about globalization, SSP1 would imagine connected markets, regional production, so it would reduce the carbon footprint in that sense of transportation, waste, and the associated bad effects. SSP2 would look at semi-open globalized economy. SSP3 would go for deglobalizing and regional security, so the multiple players will begin to have self-interest that is not necessarily synergistic with global mitigation plans. And SSP4, globally connected elites. So this is a control that is wrestled away from the developing countries or economies in transition, and these are in SSP5 it is strongly globalized. So the impact back on climate and the system and the biophysical biogeochemical feedbacks are obviously complicated, as we saw, but we will see that these have an impact on land use change as well, because they're all related to land biosphere. So assessing the potential for synergistic outcomes from ecosystem based adaptation mitigation actions, then will the action reduce greenhouse gas emissions or promote sequestration of carbon? These are the questions we have to go after. Continue to be viable for a range of plausible future climate scenarios that we are imagining, including meeting the targets of global warming with the probabilities we set. Increase the resilience of biodiversity to climate change. So it's not just about temperature target, but also other species and biodiversity. Help people adapt to climate change. So reducing climate disparities, worrying about climate justice, not just let winners and losers battle it out. Maintain or enhance the biodiversity of a region now and under the future climates. Maintain or increase the provision of ecosystem services on which the local people depend, including water, food, materials, now and under future climates, and lead to the displacement of emissions to another location. So this is the rich versus poor, or let's say tropics become uninhabitable and cannot adapt and just become sources, whereas all the benefits accrue at temperate latitudes. So you then just are shifting emissions to be high in the tropics with amplifying feedbacks, and then you are having better air quality, water quality emissions at other places. This is a potential outcome if things go haywire, right? Okay. Looking at the role of natural and semi-natural ecosystems in adaptation to and mitigation of climate change, I will show another diagram of this sort. The options here include reforestation, forest creation in unsuitable areas, river restoration, wetland restoration, protection and expansion of natural, semi-natural areas, increased connectivity for habitats and biodiversity preservation, species translocation, and natural fire regime restoration. Why am I reading these through? Because these are the land biosphere terrestrial mitigation options. So you look at climate change, you look at positive and negative impacts. So negative impacts on climate change, on people from climate change, negative impacts and feedbacks with the ecosystem. But climate change impacts on ecosystem could be negative, but ecosystem-based mitigation can make positive impacts from the ecosystem on climate change through biophysical and biogeochemical feedbacks. Okay, so these again, adaptation for biodiversity in this direction from people to ecosystems, and ecosystem-based adaptation considering ecosystems for the people. Okay. I have a few more points we will conclude, like sustainability, but we are coming to the close of the chapter. I hope the points are clear and the goals are clear in terms of land biosphere in climate change mitigation.